having that table that we did on the check-in quiz, I think it's a great foundation for the messiness that we're going to see today. So, okay, so let's get into some notes, and then and we'll take our time with this. Okay. Okay, so page 10. Okay, so this is phase shift. Okay, so we know what the A does. We know that the A is the amplitude. It affects the amplitude, but it also affects the reflection, depending if it's positive or negative. Second is the B value. We know what the B value does. The B value has some helps us find the period or the cycle, the full cycle of the trig function of the sine and cosine. But there's a little bit of adjustment we have to make today, so we'll have to deal with that a little bit. But really, we're talking about the C value. Okay, so this is C value that's either added or subtracted inside that theta, inside the trig function, and that's either going to shift the graph left or right. Tomorrow we'll talk about plus D. Plus D is where we're going to take the graph and we're going to shift it vertically. Okay, but today we're just going to focus on this C here. Okay. So phase shift. This is a horizontal shift. The C tells us the direction that is opposite of what you would think. Okay, and then we must factor out that B to see the phase shift. I think that's the hardest part, learning to factor out that phase shift, that B value. So we'll do one where we don't have to factor out first, and then we'll transition to the ones that we do have to factor out. But I find this is the one that's most troublesome, the part that's most troublesome for us, but we'll get to that. Okay, so now phase shift, the reason why it's opposite of what you think is because and we'll talk about that okay, so here for number one here, y equals sine of theta minus 3 pi over 4. So the thing is that we want to make sure that the theta is by itself. If theta is attached to anything at all, we got to factor it out because that's going to impact what we are really able to see. Here, there's no number in front of theta, so it's just a 1. So technically, we can just factor a 1 out, and that's not going to impact anything, but it's just kind of good to. I like to use a bracket here. And I think, yeah, let's do that. Let's just always kind of get into a habit of putting a number here. If it's a 1, we don't have to do anything. But if it's anything other than a 1, because it's attached to that theta, it's going to have to influence this number. Okay. But right now, that minus 3 pi over 4 is going to take the sine graph and it's going to shift the graph to the right 3 pi over 4. And that's what that means. Its direction is opposite of what you would think. Minus is moving right, plus is moving left. So here, we're going to shift the graph right by 3 pi over 4 units. Okay, number 2. Okay, number 2. Yeah, so this is what's messy here. Having to deal with this 2 theta, because the theta is not by itself. We got to get that theta by itself, meaning that I've got to either it's a 1 or it has to be another number. So here, let's go ahead and do that. I'll do a bracket 2. I got to factor a 2 out. I got to get that theta by itself. But because I factored that out, I got to think about what needs to go in that space, because that 2 is coming out, so that's going to influence what's going to come here. So the question we're going to ask is 2 times, let me see. Okay, 2 times what will give me pi? Yeah, pi over 2. We have to make that adjustment because I want this to look the same as this if I were to distribute the 2 through, right? 2 times theta is 2 theta. 2 times pi over 2 is going to be 2 pi over 2. So generally, I would say the cleanest thing to do maybe is that whatever number is out here, we have to make sure that we balance out with a number on the other side so that this can cancel out. Okay, but we'll get more practical with that. I think this is the messiest part of this process, trying to get this to work. But basically, the question we're always asking is if this is a number other than the 1, I got to ask myself 2 times what will give me this. So basically, if I distribute through, I got to be able to get back to my starting point. Okay, so now that we've factored out that B value, so that's a clean B value, we now know that there's a phase shift. That number is a true reflection of the phase shift. So what do you think is going to happen? Good, to the left by pi over 2. So anytime you see a plus or minus inside the parentheses, you just got to think opposite. Negative is right, plus is left. Why is it opposite? The reason why is because this graph is compensating. So it's subtracting 3 pi over 4 in order to get to the graph that it's supposed to look like from the original. So if I were to graph, ultimately it's because it's inside. It's inside, so it's not quite working the way that we would expect it to. If it was a +3 or +4, it kind of shifts up and down naturally, but ultimately it's because it's inside that theta. Yeah, I do want to kind of give you a better answer, but yeah, let me work on that so I can give, because right now it seems it's kind of convoluted. Okay, but yeah, but I will work on trying to get something where it's you see exactly why it's opposite, but it's having to compensate for that minus, so it's doing the opposite to get that graph to show up. Okay, so it's going to shift left by pi over 2 units. Okay, so now we're going to try to practice putting some things together from the previous section. So involving amplitude, period, and phase shift. Okay, so number 1 says write an equation of the sine function given the following information. Amplitude is 3.5 and a period of 14 pi. So here there's no phase shift. We just have to worry about how to get the A and B values. So we know A is 3.5. Now, technically, we could say plus or minus 3.5 because it doesn't, there's that possibility of reflection, but we can just always do positive if we wanted to. Period is 14 pi, so just like on the quiz, you knew that you got to go through this formula, right? Period is equal to 2 pi over b. So the period for this problem is 14 pi. Okay, just like on the quiz, right? You cross multiply, try to solve for b. B is 1/7. So there's no phase shift. So all we do is we just put the A and B value where they belong. There's no need for all these brackets and parentheses here. So y is equal to 3.5 sine. Well, I like to put parentheses just so I can as a reminder that the 1/7 pi is inside. The trig function is not It's not sine times 1/7 theta, it's sine of 1/7 theta. Okay, so that's nothing new, right? That's review. Okay, number 2, amplitude of 1/2, period of 1/3, and phase shift right 1/2. Okay, so we know our A is 1/2, our period is 1/3. So I'm just going to plug into my formula. P equals 2 pi over B. So 1/3 equals 2 pi over B. Cross multiply. Okay. Phase shift is to the right 1/2. So we know we have to, that's going to be the C value. That's going to be what's added or subtracted inside that parentheses with the theta. So Y is equal to sine bracket, our B value, 6 pi theta, and then what do we do? Minus or plus 1/2? Minus, yeah, opposite here. That B is always going to be factored out, okay? Otherwise, yeah, it's not gonna, we're not able to get that true feel for what's really happening unless that B is outside the set of parentheses. Okay, let's skip number 3 and 4, and let's just go down to number 6. Okay, so number 6, let's do one. Does anybody still need to look at this? Yeah. So we'll try number 6, and number 6 is just a review from the previous section. So I wanted to get that whole table set up so we kind of have that as a reminder, and then we'll bring in the phase shift with the back page. So number 6, you may want to start putting this onto your separate sheet because well, it's not too bad. I guess you could use the entire space for number 6 below, since we're going to skip number 5. So I think the space below is enough for number 6. Okay, so number 6, just review. Okay, your A value, your B value, and then we're going to create our table, and we're going to get the graph going. Okay. All right. So as you guys work on it, I'll work on it at the same time. And PS is phase shift. And right now we don't have any phase shift because there's no plus or minus inside that theta, right? So this is a review problem here. So after we create our parent sine graph or sine y value, then we multiply all of those numbers by -4. Okay, review, right? Now, what phase shift is going to do, it's going to force us to have to change these x values. But we're going to still build our foundation first, and then we'll worry about the phase shift. Okay, so basically, we're going to create the same graph, same information, same table for number 7, but we'll leave room for the phase shift that we're going to do. But the first steps is going to feel the same. Okay. Any questions with 6? So we find our b value, we go through our period formula, 2 pi over b, we go through our interval formula, taking the new period divided by 4, so we can subdivide and identify those easy y values that we want to graph. Okay, let's go to the next page. Okay, page 11. Now, I'm going to do this on a separate sheet. I encourage you guys to do as well. We just want to make sure we have plenty of room. And I'm sorry that I squeezed all those problems on there that we're not going to have space to work on. Okay, so number 7. I'll unfreeze in a second. Okay, so here's number 7. All right, so we see that there's a plus pi over 2. We know there's going to be a phase shift, but there's something standing in the way from getting, this is not truly the phase shift because that 2 is not factored out. We need that theta by itself. That 2 needs to be pushed out. So we're going to rewrite it. Y equals 5/3 cosine bracket 2 parentheses theta. Okay, so we know this number has to be different. We have to ask ourselves, 2 times what will give me pi over 2? Pi over 4. Yeah, so basically, when the number comes out, that number needs to be in the other side to balance that out. So if you factor out a 2, then I need a 2 in the denominator. And that 2 in the denominator is going to combine with that 2 that's already there. So that's going to be pi over 4. Does that make sense? And we can always double check ourselves, right? We can always double check ourselves. Can I get back from here to here? 2 times theta is 2 theta. That's good. 2 times pi over 4 is 1/2 or pi over 2. So whatever steps we take, we should always double check and make sure, okay, did I take that step right? We always have a clear way of confirming that we did this correctly. Okay, good. So let's do the easy part first. Okay. A is 5/3. B is what? 2. Okay. And let's go through our process, right? So period is 2 pi over b. Interval put a star next to phase shift because we'll do this later. What's the phase shift? Remember, we're looking at this now, right? We don't want to look at this anymore. What's the phase shift? Yeah, pi over 4 to the left, okay? Okay, so let's create our table, but we're going to give ourselves more room this time, okay? So start off with beta. Make every column really wide. For now, just let it take up the entire length of the paper until you feel more comfortable, and you can decide how wide you want to make it. If you want to make it shorter, you can. But for now, just make it as wide as possible. We just want to have as much room as we can, and give yourself some space up here as well. Okay, so we got five slots, right? Okay, so we're going to start at 0, and we're going to keep adding by what? Good, our interval, right? So right now, nothing's new yet. Okay, so we're still, but give yourself plenty of room though. Just put the number at the left edge of each subinterval because we need the space for something else. So 0. So pi over 4 plus pi over 4 is 2 pi over 4. For now, I'm not reducing yet because I got to do something with this, and it's just easier potentially to just leave it in unsimplified form because we got to do that phase shift portion. Okay, but our second row, right? Where does cosine start? 1. Okay, we're not going to add anything to the second and third column, so you can put your numbers in the center. That's fine. Then we go down, -1, 0. And we know that that the a value is going to impact my parent y values. So multiply everything through by 5/3. So far, so good, right? Nothing new except for the fact that we had to factor that 2 out and understand there's a phase shift. So now we got to worry about that phase shift because this graph hasn't been shifted yet, right? We got to shift this graph. So we're going to have to shift to the left by pi over 4, which means that we're going to take every point of our graph, we're going to subtract it. We're going to shift it left. Okay, so we're going to do this. We're going to subtract each x value by pi over 4. Okay, we're taking that active step to shift it left. So giving us all this space here, so we can do that. So you can say 0 minus pi over 4 minus pi over 4. Right, every point we're just forcing it to shift. Does that make sense so far? So now let's find out what the new x values are, and let's put it in the space above. So what's 0 minus pi over 4? Negative pi over 4. Put a box around it because it's really the new x value that we're going to look at. What's pi over 4 minus pi over 4? So it's nice, right? It's nice to have it unsimplified so that we can have an easier time subtracting. What's 2 pi over 4 minus pi over 4? Okay, next. 2 pi over 4. If you want to reduce it to pi over 2, now you can do that. And then 4 pi over 4 minus pi over 4 is 3 pi over 4. So what you're going to be plotting are the outer edges of your table. So you're going to be looking at the top row and the bottom row. Everything in the middle is just information that you're gathering to get to where you want to go. Yes.
What about the
That's right. Yeah, because we're not starting at 0 anymore, we're not going to be landing at the same place as we were hoping for with that pi. Yeah. So, but we did take into account period, right? We did take into account that pi and that interval. So we did take that step. But now, because of the shift, this last stop is not going to be it's not going to no longer going to be that period or that period length. But it's still the period from negative pi over 4 to 3 pi over 4. If we count that up, that distance is still pi. Okay, so we're just going to graph one cycle of this function. Okay, and we're just going to pay attention to the x and the y. Okay? The middle ones we're no longer going to pay attention to. So now we're going to start at negative pi over 4. So 0 is also one of them. Pi over 4. Pi over 2. And 3 pi over 3. We're going to go as high as 5/3. Go as low as negative 5/8. So now you're just going to plot your order pairs. Okay, first order pair is negative pi over 4, 5/3. So negative pi over 4, go to 5/3. Second order pair, 0, 0. Next order pair, pi over 4, negative 5/3. Next up, pi over 2, 0. Next up, 3 pi over 4, 5/3. Now the graph should look like the cosine graph, but it just feels like it's starting to the left of where we would expect it to start. We can still see that cosine graph, right? It just feels like it's, instead of starting at 0, 0, is now starting, it's getting shifted left. Okay, does that make sense? Okay, so we're just going to be working on this for today, and I think for most of tomorrow as well. Okay, so let's just see how far we can get, and whatever we don't finish, we'll just continue working on it tomorrow. So let's go to number 8, and you see how much space this took up, right? And I want you guys to have plenty of space to do everything you want to do. I never want to feel like, want you to feel like you're restricted. So if you want to go to the back, you can, or if you have space in this bottom half of the page, you can. But does anybody have any questions? Does anybody want to look at anything else that I have up here? Okay, let's go to number 8. I'm going to flip the page here. Okay, do I have to make any adjustment here initially? No, right? That data is already by itself, but I just like to force myself to see that B value. That way, every problem can look the same. Right, but if you don't have a theta, you know that you don't have to factor anything out. But I'd like to put a 1 there as a reminder. Okay, my B is 1. I'm not gonna have to worry about my phase shift being a different number. It's gonna be the same. Go through the same process. I'm gonna have you guys try it, and I'll work through it at the same time you're working through it. Okay, your phase shift will be the last thing that you do. Okay, so do all the things that you've done. Just make sure you give yourselves plenty of space and also some space above so that you can do the calculation. So as I'm building my original X value, I like to force the same denominator because then I can just, if I need to make an adjustment, I can just make it the same denominator and it'll be easier to add and subtract, right? Because dealing with fractions without a calculator, anything that we can make it easier to add or subtract, we want to do that. You should end up with 4 rows and then you're just graphing the top row and the bottom row. Okay, let's do one more, number 9. Yeah, how we can get 4 times. Yeah, if you need more paper, come up and grab any that you need. Yeah. Okay, does anybody still need to look at number 8? Everybody okay? All right, here's number 9. Okay, this requires some cleanup, right? Okay. What is stuck to that theta that we don't want? 1/4. So we need that 1/4 to come out. That theta needs to be clean and by itself. Out. There's a 4 here, so I need to compensate with a 4 where? The top in numerator. Good. So if I'm forcing a 4 in the denominator, that's going to force a 4 in the numerator because I gotta have balancing things that comes out. So really, if that 4 is now up here, does that make sense? So really, whatever number that you see out here, you're just going to take that number and put it in the opposite side for your C value. Now, what do you know about 4 pi over 8? Thing is what? Pi over 2, right? So we can clean that up just to make it a little bit easier to look at, but you know, I think that's where we start. We start by making sure that whatever number you have here, you put it on the other side. Then you can reduce if you like. Four over 8 is the same thing as 1/2, so that's why it's pi over 2. Okay, so now we can go through our process. what's our phase shift here? Which direction is this gonna go? Right, pi over 2. I gotta add pi over 2. We got to add those fractions, clean it up, and ultimately we'll have the top row and the bottom row, and we'll graph those 5 points. Okay. All right, we'll pick this up tomorrow. Don't forget your phones. It's kind of long.